These are the notes for Algebra 2, Section 7.5. We're dealing with properties of logarithms. Now there are three properties of logarithms that we're interested in. They are actually related to the exponent properties. Not terribly surprising considering the fact that logarithms are the inverses of exponents. So these should look kind of familiar. For instance, the product property says that if I have log base b of m times n, that is two things being multiplied together, I could rewrite that as log base b of m plus log base b of n. This is almost identical to the exponent multiplication property, where we add the exponents together. The quotient property, again, very similar to the exponent property, says that if I have log base b of m divided by n, I could rewrite that as log base b of m minus n. Again, related to the quotient property from exponents. And the power property, again, very similar to the other power property, a little bit different in this case, though. In this case, if I have log base b of m to the n power, log base b of m to the n power, this n will move to the front of the logarithm, and I will be multiplying by it. So I would rewrite this as n times log base b of m. So you can see it's similar to the power of a power property in that we're multiplying, but it's a little bit different in how we do the multiplication. The n comes out front and multiplies that way. Let's do some examples to deal with these properties. Now in this case, we're going to use log base 5 of 4 being 0.861 and log base 5 of 9 being 1.365 to help us answer some questions. Since we're told what these two values are, we can be sure that we're probably going to want to figure out a way to rewrite our logarithms using the properties into these two logarithms. Now we start with A. We have log base 5 of 4 divided by 9. Well, according to our quotient property, if I have m divided by n, I can rewrite that as log base 5 of 4 minus log base 5 of 9. So instead of having one log where I'm dividing, I'm going to have two separate logarithms that I'm subtracting using the quotient property. Now, next thing I want to do is replace my logarithms with their given values. So that would give me log base 5 of 4 is 0.861 minus log base 5 of 9, which is 1.365. And any calculator in the world can do this subtraction for me. When I do subtract it, I get negative 0.504. And that is my answer. Now, here I have log base 5 of 36. Now, you obviously can see that 36 is neither 4 nor 9. However, 36 is 4 times 9. So we're going to rewrite 36 as 4 times 9. Since I now have log base 5 of 4 times 9, I can use the product property to rewrite that as log base 5 of 4 plus log base 5 of 9. And of course, I can use my given values just like I did before, 0.861 plus 1.365. And again, I can add these together in any calculator and get 2.2 0.26. And that is my answer. Right, we have example C. We still have the same values for the logarithms. Log base 5 of 4 and 9. This time, though, we're given log base 5 of 81. 81 is obviously neither 4 nor 9. However, 81 is 9 squared. So I'm going to rewrite 81 as 9 squared. That will be my first step. I now have log base 5 of 9 squared, which according to the power property means that I would take my little exponent here, move it out to the front, and I will now be multiplying by it, giving me 2 times log base 5 of 9, which is one of my values. I can substitute in my value, of course. I would get 2 times 1.365, which in any calculator would give me 2.73 as my answer. So that's how we can use the product properties to simplify or evaluate a logarithm, assuming we know a couple of values. We might also be asked to use the properties to either expand a logarithm or to condense it. Let's start with expanding a logarithm. Now, when we expand a logarithm, what we want to do is we want to take all the stuff that's going on in this logarithm, we want to break it down into its individual parts to get a series of logarithms being added or subtracted, and so on and so forth. So let's start with this. This is log base 3 of 7x squared divided by y. Right? This whole thing here is what I'm taking the log of. Now, usually I'll want to start with my quotient property. That's where I'll want to start. That means if I have division, I want to do that first. And the quotient property says that if I have log base 3 of 7x squared divided by y, I can rewrite that as log base 3 of 7x squared minus log base 3 of y. Okay? That's the quotient property. I split the division off as subtraction. Now, after I've done that, I can no longer do anything with log base 3 of y. Right? It's as simple as it's going to get. It's as expanded as it's going to get. However, log base 3 of 7 times x squared has a couple of things I can do to it. And what I want to start with is the product property. So I'm going to do quotient, then product, and then power if I need to. But I'll always usually want to go, I'll always want to go in that direction, unless it's a special case. So using the product property, I can split 7 times x squared into log base 3 of 7 plus log base 3 of x squared minus log base 3 of y. Notice the log base 3 of y didn't leave. It's still there. Alright, now I have log base 3 of 7. I can't do anything with that. I have log base 3 of y. I can't do anything with that. Log base 3 of x squared has an exponent. So that power property comes into play. That exponent can move out to the front here and become multiplication, which would give me log base 3 of 7 plus 2 times log base 3 of x minus log base 3 of y. And this is the expanded form of log base 3 of 7x squared divided by y. Alright, if we wanted to condense the logarithm, as you can see here, we can use the properties again. Let's see here, I have log of 2 plus 3 log of 3 minus log of 9. Now, since I started with the quotient property, then went product property, then power property, when I expanded, usually when I condense, I'll want to go power property, then product property, then quotient property. Right? It's not necessary to do it that way every time, but it does make life easier in the long run. So we start with the power property. Now, according to the power property, we have this guy here. And as you know, the power property says that if I have the log of x squared, that can become 2 log of x. Yeah? Well, it works backwards too. If I have 2 log of x, that can become log of x squared. So that's what we're going to do. We're going to use that property backwards to go from 3 log of 3 to log of 3 cubed. Notice the log of 2 and the log of 9 did not change. Now that's our power property. We are going to use the product property next to combine these two guys. As you can see, I've got log of 2 plus log of 3 to the third. The product property says I can combine them with multiplication because I'm adding them. That gives me log of 2 times 3 to the third. Again, notice the log of 9 hasn't changed yet. Since I'm subtracting log of 2 times 3 to the third, I can, and log of 9, I can use the quotient property to combine that with division. Gives me 2 times log of 2 times 3 to the third divided by 9. Now I can work this out to simplify it. 2 times 3 to the third. 3 to the third is 27. 2 times 27 is 54. 54 divided by 9 is 6. So when I simplify this, I get log of 6. And that is the condensed form of this logarithm. All right, we have one last thing to look at when it comes to properties, and that is the change of base formula. The change of base formula is useful if we have logarithms that aren't in base 10 or base e, right? They aren't the natural or the common log. We can change any logarithm to any other base using this formula. Normally, though, we want to use the common log and natural log because those are what our calculator can handle. So, if I have log base c of a, I can change that to base b by doing log base b of a divided by log base b of c. Right. In particular, if I have log base c of a, that is the log of a divided by the log of c. Right, the old base is on the bottom, the big number is on the top. That looks like a 9. Let's make it look like an A for all the people that aren't listening to this. If I have log base c of a, this could also be the natural log of a divided by the natural log of c. And this will work out either way. If we were to type this into our calculators, we would get an answer. So, let's give that a shot. If I have log base 6 of 11, of course I can't evaluate that very easily. So what I want to do is do, with the common log, log of 11 divided by log of 6. I'm not going to worry about the intermediate step. I'm not interested. What I am interested in is typing this guy into the calculator exactly the way it's written. Keep in mind that if you are using a graphing calculator, you need to close parentheses around these numbers. And we get 1.3383. So that is 1.3383 is log base 6 of 11. They're equivalent. If I wanted to do this using natural logarithms, I could. It would be natural log of 11 divided by the natural log of 6. I type this into the calculator exactly the way it's written, keeping in mind that I need to put parentheses around the 11 and around the 6. Again, I'm not worried about this step here. But I should end up with 1.3383, an identical number. They mean the same thing, because the log base 6 of 11 is 1.3383. So using this, we can convert, or we can evaluate any logarithm using the natural or the common log. So it's kind of nice.